don't think they're not supposed to do right.
By the way, ladies and gentlemen, since people are turning them in, I do not need you to turn in the data table part.
But it's marked as missing.
I will change it to something, but don't turn it in. Most of the things you do bother me, Shenza. So. All right, ladies and gentlemen, take out your periodic tables, your solubility charts.
Yes, I will. I don't have time.
Name me a compound that will precipitate when put in water.
AGI.
Silver iodide will precipitate when put in water. Very good. What? Why? It's not what you keep telling me on your tests. I am smart. I am smart. Now today, I am stupid. Make up your mind. You only get to pick one out of the two. We got silver iodide. Will precipitate when in water. Give me another one. Lead what?
Chloride.
Lead chloride will precipitate in water. What?
Lead chromate.
Lead chromate will precipitate in water. PbSO4. Are you saying that because you don't know how to say the name, or
I don't
just
know what SO4 is.
sulfate?
Sulfate off the top of my head. Or are you saying PB like PB? Yeah, but it's initial.
You need to give us one JVB instead of just laughing all the time. Let's go. Is not one of them. No, there is no on the periodic table.
Barium chromate.
Barium chromate. Yes, good,
Barium
good, good,
chromate.
good, good. All right, 90 degree.
No.
I don't know. Is it one of them? No, no, that one won't work.
Wait, the silver nitrate work.
Wait,
The silver nitrate, really?
Yeah.
Really? Nitrate doesn't precipitate with anything. Anything.
That's my B. That's my
Yeah, I know it's your B, because you're the one who said the wrong answer. Who else B with that B, if not your B?
B.
Go, Eric.
This is an all-day event, ladies and gentlemen.
Yeah, it is.
Quit laughing, 90 degree. You're next.
I got one.
Good, go.
I was waiting for Eric.
No, don't. That may take all week. Go.
Lead iodide?
Lead iodide. The same lead iodide that somebody else just said a minute ago?
Wait, really?
Why would I lie?
Who said it?
Two people.
Get in the back. Let's go. Come on. Pick another one.
Potassium chloride.
What?
Potassium chloride.
Potassium chloride. No.
Oh.
You even know what you're looking at, dude?
Oh. No.
Maddie, help him out.
Silver chloride.
Silver chloride, like the same silver chloride that was the first one we did.
Go to the next one.
Lead chloride.
Lead chloride. Good, 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 good. Finally, somebody's getting the hint. Go ahead, Kate. We're on a roll. Don't let us fall off the donut. I want something that will be a precipitate in water. Nope, is not one of them. I can't even find on the periodic table. I've looked 3 times.
Mercury chloride.
Mercury chloride. Wonderful, wonderful, wonderful. Jack, what do you got for me?
We found
Where's
Uranium, manganese.
That's not that's uranium.
Oh,
Okay?
uranium.
There's neptunium too. That's not I'm sorry, Jack. I got interrupted by people who rudely interrupted us. Go ahead. Calcium chromate. Very good, Jack. Very good, Jack. Faith. We gotta have a little faith here. Okay? Plus, I'm just buying time for Eric, who needs all day.
There's 2 ways to
What? Calcium chloride. No, I'm sorry. Look at this sheet. Look at this sheet. Thank you. Do you got one, Skylar? Anyone? I want something that will precipitate. Notice everybody's avoiding that bottom table where all of the precipitates are. Well, give me one that involves sulfur, hydroxide, carbonate, or phosphate. Because everybody's avoided those like the plague.
Wait. Is it? Sure, yeah. You sure? Yeah.
What's that? CRO? Well, you could do one with chromate, but you got to pick one. What else would it be with? You're looking here, right? Chromate.
I would take a picture of it and be like,
Okay, which would make it silver chromate. Good. Faith, you got one? Eric. Okay, we'll move on. Ariana. Give me something that will precipitate with sulfur. Look down at the bottom of your periodic. Hey, this one. Look down at the bottom with sulfur. Tell me something that will precipitate with it. So what won't precipitate with it? You're looking at the bottom, right?
Yes.
For sulfur -2. What things will not precipitate with it? Okay, and? And what else? So read what it says next, Ariana. In that middle box, NH4 and what?
Cations of group 1 and 2.
Okay, so these, ladies and gentlemen, are the cations of group 1 and 2. Cations are positive ions, okay? So you cannot put sulfur with sodium and precipitate. You cannot put it with calcium. It will not precipitate. You cannot put it with rubidium. So pick a metal that is not in group 1 or 2. Ariana, any metal that's not in these 2 groups, pick one. You've got a bunch to choose from. Pick one.
Copper.
Okay, so copper what? What would be copper with S called? S in the compound, Ariana. What would we call it?
Sulfur.
Well, we changed the ending to.
ID.
Okay, so give me the compound. Tell me what it would be. Put the two names together.
SCU.
Well, what is Cu?
Copper.
And with S it would be. What did you just say? S becomes in a compound. Sulfur becomes.
ID.
Okay, so what is that?
Sulfur.
Okay, so put it together. What sulfide? Give me the name of your metal.
Cu.
Give me the name of that. That's the symbol.
Copper.
Now put it with S.
Copper sulfur.
Thank you. There you go. Copper sulfide. Jasmine, give me one.
From the bottom.
Where? That would be the best place because no one is. That was the first one we've done from the bottom. Can you give me another one from the bottom?
Silver hydroxide.
Silver hydroxide. Good. Eric.
Cobalt.
Again, all this still not on there.
Cobalt hydroxide.
Cobalt hydroxide. Joshua.
Tungsten sulfate.
What's that?
Tungsten sulfate.
What's the? I'm sorry, I'm not catching the first one you're going with.
Tungsten.
Tungsten. Okay, tungsten sulfate. SO4.
Or
Be careful. The bottom is just S, which is what?
sulfate.
Which we would do what for the name? If it's just sulfur, what is the name ending?
Sulfite.
Sulfide. So give me the name again. I'm sorry.
Tungsten sulfite.
Good. Pierce.
Lithium carbonate.
Lithium carbonate. Good. Got the exception there. Go ahead, Irving. Tin sulfide. Good. Achilles. We were doing so good. We were just cruising on along. Even Eric got one. What? Aluminum sulfide. Very good. Shenza. Shenza, I am smart. Go ahead.
Flavor. Fate.
Silver sulfate.
The last one.
Silver sulfate.
Yeah, SO4.
Silver.
Yeah, silver.
Okay. Jaden?
Nickel sulfite.
Nickel sulfide. Good. Questions? So, think about it, ladies and gentlemen. This chart, you're going to need to use this because what kind of reaction do we need to use this for?
Precipitate? Or like
That's not a kind of reaction, but you are right. We do need it to identify a precipitate. What kind of reaction? Double replacement. What are the three things that we need to find in a double replacement reaction that tells us it actually happened? One of the three things. You are participating. What I need you to do is precipitate. Precipitate. One. What's the other two? No. Because precipitate is the opposite of being aqueous. Aqueous means you will dissolve in water. If we find a precipitate, the reaction happens. Nope. That is a precipitate.
H2O. Water.
Water. H2O. Why didn't you go with that one earlier? You spit that one out right away. What's the third thing? A what? Tells us a double replacement reaction has occurred. A precipitate, water, and a gas. And a gas. Now, on the other side of the table are the single replacement reactions. Why would a single replacement reaction occur?
Higher level.
Why would a single replacement reaction occur?
They have higher level.
It'd have higher level.
Yeah.
You're leaving out just like a lot of details. Higher level.
Yeah.
Higher up. What has to be higher up? One of your two metals. Good, because if you got two metals, you don't want them at the same level. One of them has to be higher up. Okay? So, single replacement reaction. What plus what produces what plus what?
Lower
Metal.
More general than metal. Think in terms of substances. What? Element and what? Produces? Good. So, for a single replacement reaction, ladies and gentlemen, element and compound produce element and compound. Now, you said one has to be higher up, one has to be lower down, correct? Okay, which one has to be higher up? Okay, please remember, this element is normally a metal. This compound contains what?
A metal and a non-metal.
And a non-metal or a polyatomic. A polyatomic anion, a negative ion, correct? So you've got a metal here and a metal here. Which one needs to be higher up? The what? They're both on the right side. Or actually, they're both on the left side, Shenza. I don't know what you're looking at. For a single replacement reaction to occur, this metal goes in and replaces this one, correct?
Yeah.
This one then leaves. What do we know about this metal compared to this one? Okay, they are. I agree. Why would one metal go in and replace the other? So, Phoebe, you're dating a guy. You go to the dance with this guy. But at the dance, you meet a different guy, and you decide to dump the guy who you're with for this other guy.
I would not do that.
Okay, whatever. We'll believe that later on. Why would you choose to pick some other guy over the one who you were with?
I don't know.
Baloney, you know. Go ahead and tell us.
He dances better.
Maybe he's just
What?
nice or
Okay. There's got to be something about him that you like more, right?
yeah.
Okay. He's nicer, he dances better, he's better looking, he treats you better, whatever it is. But you may leave one guy and start dating another, correct?
Yeah.
Okay. Well, in the chemistry world, why would that one metal replace the other one in the compound? What about this metal means that it says to this one, dude, you're out of here.
It's better than that.
Okay, but chemical world, we can't talk about better. We could talk about what though? Being
More reactive.
more reactive.
Oh.
So in the chemical world, it is the more reactive metal that will replace.
The less reactive.
How do you know which is the more reactive metal?
This sheet.
Okay, could you explain a little bit? Because there's all kinds of metals on there.
That is true.
The more reactive it is on the
How do we know which one is more reactive? You guys are doing a great job of not answering the question.
it's the higher it is.
Okay, the metals that are higher up are more reactive than the metals that are lower down.
Yeah, that's what
But that metal has to be here, the more reactive one. Because that's the only way it can replace this one. Okay? That's the only way it's going to. If the more reactive metal is here, you're not going to replace it. If you are already with the guy who treats you better, who is nicer to you, who dances better, who is better looking, you're not going to replace him with the other schmuck.
Yeah.
Okay? So, again, There has to be something that causes that metal to replace the other one, and that is reactivity. That is reactivity. Questions? I wonder if there's a reason I'm reviewing this before the test. Okay, questions? Wonderful. All right, ladies and gentlemen. Final topic. Here we go. Ions. Ionic compounds in water. When you have an ionic compound in water, one of two things can happen to it. It is either what or what?
It'll dissolve.
Or
stay the same. Or do nothing. No reaction.
gosh, I wish we were paying attention 10 minutes ago.
Oh, I was. Enough. I get one of them.
What are the two things that can happen to an ionic compound in water? What? Dissolve. What do we call that? Being what? Being aqueous. Gosh, if that wasn't a hint, I don't know what is. What's the other thing that can happen? It could be a precipitate. We need to find the precipitate to be able to know the reaction occurs. But guess what? If something stays aqueous, we can still talk about it. Now, what or how do we measure aqueous solutions? Yes, we measure them with an AQ. A is good, Q is bad. AQ together is E. No, come on. What information are you given about an aqueous solution that allows you to use it in our problems? Could be either what or what. Well, we know it's not PV equals nRT because it's not a what? What?
Pressure? Oh, wait.
A solution is not a what for PV equals nRT? Gas!
Thank you.
Only gases get to use PV equals nRT. Now, what are the two ways that I can give you information about a solution? Because there's only three ways I can give you information in this entire unit. I can give you the volume of a gas at conditions.
Oh, forget about STP.
Forget about STP.
Forget about STP.
By the way, we're not talking about gases.
Yeah.
What are the two ways I can give you information about a solution? Have you done any of the problems I've given you this? What?
Nice.
I can give you the mass.
Wow.
I can give you the mass. Volume of what?
Of the solution.
Volume of the solution. But if I'm giving you the volume of the solution, I also have to give you the molarity. The molarity. Okay? So let's take a look at that. This is...
I don't have that slide.
Okay. You don't have that slide? You don't have slide 23?
Oh, wait.
Or is that 29? I can't tell. 29. Dissociation is the splitting apart of a soluble ionic compound in solution. We have already done this. We did this in the first trimester.
Yeah, we don't have that.
What?
We don't have that.
You don't have this slide?
Oh no, we don't. I don't either.
Yeah, you do.
You just have.
How can half of you have it and half of you don't?
Oh, no,
You're just not
we
looking
do,
right
they just
now. No,
didn't
I
get
did the
the
same
right
thing you
thing.
did. I was like, wait, it's not the right one. But
It's not just that. It's
Oh.
Well, I haven't gotten to that yet. Okay. No, my bad. Now we're good. Now we're understand good.
Yeah.
Dissociation is the process of the splitting apart of a soluble ionic compound into water. In other words, when you put a compound that is ionic into water, it will break apart into the ions that make it up. We've already discussed this. We did this in the first trimester, Unit 4. We talked about a net ionic equation and an overall ionic equation. Okay? So, if we have a compound like salt and we put it into water, it will break apart into sodium ions and chlorine ions. Any questions about that? Okay. So if we have 2.25 molar NaCl, that's the molarity, correct? What's the molarity of sodium ions in solution? What?
2.25.
2.25. Why? Well, if we take 1 liter of solution because all these have to be in the same amount of solution, correct? If this is in solution, this is in the same amount, right? Okay, so let's take 1 liter. Why? Because you can pick whatever amount you wanted. It isn't going to matter. So we're going to pick 1 liter. We're going to take it times the moles over liters to get 2 moles of sodium chloride. What is the next step of our process in a problem always? Molar ratio. Our molar ratio, though, is between the moles of sodium ions, Na, and the moles of sodium chloride, which happens to be a what ratio? 1 to 1. So that means I have 0.225 moles of sodium ions, correct? How much solution is it in? 1 liter. So guess what that means its molarity is? 2.25. 2.25. What would be the molarity of the chlorine? What? Why?
Same ratio.
It's the same ratio. So chlorine, we need to end up with the same molarity as well. So what does the molarity depend on?
The ratio.
Depends on the ratio. You're right, it does depend on how many moles, Shenza. But the moles depends on the ratio. Well, the ratio of sodium ions to NaCl is 1 to 1. The ratio of chlorine ions to sodium chloride is still 1 to 1. So whatever the molarity here is, this and this will be the same, correct? Good. What's different here?
Different elements.
Okay. So you've got magnesium nitrate. It is aqueous. It will break apart into magnesium ions, correct? And nitrate ions, correct? What do you notice about the nitrate ions, though?
There's a 2 in front of it.
There's a 2 in front of it. What does that mean? Well, if we start out with something like 0.565 molar magnesium nitrate, what's going to be the molarity of magnesium ions? Okay, let's figure it out. 1 liter times the molarity times the ratio means 0.565 moles, correct?
Yeah.
Still in 1 liter, which means the molarity is 0.565 moles. Or I'm sorry, 0.565 molarity or molar. So that's what is here. But what happens with this one, ladies and gentlemen? Why?
Because there's a 2.
So your molarity here, ladies and gentlemen, actually doubles. Why? Because magnesium is in a 1 to 1 ratio, which means these are going to be equal. This is in a 1 to 2 ratio, which means this is going to double. Double. This is going to double. So, in solutions, if you talk about this breaking apart into ions, it still comes back to molar ratios. 1 to 1, the molarity is going to stay the same. But 1 to 2, the molarity is going to double. What about 1 to 3? What about 1 to 4? There you go, ladies and gentlemen.
So on.
Okay? And so on. So here, we've got a 1 to 2 ratio, correct? What happened to our molarity? It doubles. 2.32. Here you've got a 1 to 3 ratio. It triples. It triples. What the heck did I do? Hang on a minute here. Oh, sorry. Yes. Sorry. My bad. I missed the 1.16. I was looking at this thinking this should have tripled, but yes. Double, triple. Questions? That's them driving the pylons in behind the gymnasium, yes. Yes.
I was gonna say I didn't hear it in this room before.
Nope, I didn't hear it either until the other day when I was working in here alone, and I'm like, "What the heck is going on?" And I realized what it was. So, questions?
I've been really bad for the laugh we did when we were playing. If it was like shaking in the room. Yeah.
I'm sure there's worse things that could have happened. All right, ladies and gentlemen,
That would be pretty bad.
my suggestion to you,
Like work on you.
I would do the practice test questions 5 through 10 on the last worksheet in the packet. Because those are what you're going to see on the test on Thursday. Now, you can do whatever problems you would like. If you need help with something, I am here. I can give you help with something. If you have questions about the lab that you were supposed to turn in yesterday, yet I only got a third of them turned in, please feel free to ask me those questions so you can turn in the damn lab today.
What was the last question?
What is the last question? It's written there for you. Go back to the data table and look at the moles of sodium iodide compared to moles of product and tell me what you notice. Do a little comparison. What?
For the test, so you said we have 4 questions, right? So
Yeah.
the solving one?
You said the practice
Solving
test?
question.
Why don't you do the practice test numbers 5 through 10 and you'll see what the 4 questions on the test are going to look
Oh,
like.
yeah, but then after that, is it just like, ask questions? You just ask questions?
Yeah,
That's it?
yeah, that's it.
No.
Again?
Again.
You didn't use it yesterday?
Yesterday, yeah.
Okay, so you need to use it again today?
Yeah.
No.
Unhuman of you.
So yes, there will be some questions on there about, I think, 10 points maybe that are not problems. Just a few.
So how much points in tennis?
What?
How much points in
The test is worth 76 points, and I believe I give you 18 points of extra credit on it.
Oh my lord.
Hey, we separate church and state in public schools, so you're not allowed to talk about that.
Hey.
This is not my house.
I know.
It is not a